This is the last set of identities I'm going to show you. And these ones in gray, you will be given formulas for them. Okay, you will be given these on a formula sheet. Right? So it's not just about, you don't have to worry about memorizing them, just about when to use them. And I'm going to show you some places where we use them in the next few examples. So double angle identities means we're taking the sine, cos, or tan of twice an angle. That's what double angle means. We're doubling the angle. So when we take the sine, like the sine of alpha is just opposite over hypotenuse. But the sine of double the angle alpha is going to be 2 times the sine of that angle times the cosine of that angle. There's 1 for tan, and there's 3 for cos. Okay? And you can use any of the 3. Some questions, one of these might be easier to use than the other, but they'll all work in the end. So I'm going to prove to you how we're going to get a couple of these. So I'm going to prove to you the sine and cosine points. Well, the sine of 2 alpha. Would you agree that the sine of 2 alpha would be the same as that? Alpha plus alpha. Alpha plus alpha is 2 alpha. Well, that looks familiar. We've already done an identity like this. It is the sine sum identity. Entity. So what's the sine sum identity? Remember, you'll get that one. If we take the sine of 2 angles being added together, that is the same as sine of the first times cosine of the second plus cosine of the first times sine of the second. So it's going to be sine of the first, which is alpha, times cosine of the second, which is also alpha, plus cosine of the first, which is alpha, times sine of the second, which is also alpha. Well, these are like terms. If I've got a sine theta cos theta and I add another sine theta cos theta, because that's what that means, I got 2 sine theta cos thetas. And notice that's the formula. So we proved that this is equal to this using the sine sum identity. Similarly, with cos. Well, cos 2 alpha means the same thing as cos alpha plus alpha. That is the same as the cos sum identity. And I don't expect you to have this memorized, because you do get the formula. But cos sum is the same as, what is it the same as? Even I have to find sine minus sine minus cos. Oh, I'm not sure. I'm doubting myself. I gotta look it up. Cos minus sine, not sine minus cos. So it's cos. So cos of the first one times cos of the second one, which are both alphas, minus sine of the first one, alpha, times sine of the second one, which is also alpha. Well, what's an easier way to say cos times cos? Cos squared. What's an easier way to say sine times sine? Sine squared. We just proved that one. How do we prove the other two? Well, do you remember from your Pythagorean identity, cos squared is the same as 1 minus sine squared. Excellent. That one you do have to remember. So I could write this like that. Instead of cos squared alpha, I can write 1 minus sine squared alpha. Well, I got two like terms. Minus sine squared alpha is minus 2 sine squared alpha. We just proved that one. I could go back to this original one, okay, and say instead of rewriting cos squared, how do I rewrite sine squared? Minus 1 minus cos squared. And I got to put it in parentheses because there's a subtraction in front. It's going to change some signs. So notice when we remove the parentheses, we get cos squared alpha minus 1 plus cos squared alpha again. And a cos squared alpha and another cos squared alpha is 2 cos squared alpha. And I have a minus 1. And I've just proved that one. You will not, I don't believe I've ever seen a question where you've been asked to prove it. I'm just showing you how we can prove it. So I'm not going to do 10. 10 is in the notes. You can look at it on your own if you want, but I'm not going to worry about it. Okay. But I do like, I mean, I've told you guys this before. I don't like giving formulas without explaining a little bit of why. Okay. So there are reasons why we get these formulas. Anyway, let's focus on what you could expect to see. A couple quick examples like this. This phrase here, I hope we've done enough of these. This should tell you what you're going to have to do as part of your solution. Put a right triangle on a grid, do Pythagoras. If you're given one of the trig ratios and you're told that the angle is in a certain quadrant, that means that we're going to use a coordinate grid, and we're going to draw a right triangle in quadrant 1. So it always comes out from the origin. One of the legs is always horizontal, and then connect the third vertical leg. Because we're in quadrant 1. Somewhere in the question, it will give me 2 of the sides. I have to figure out the third side by Pythagoras. Well, hopefully you're looking at this saying, okay, there's a 3 and a 5. Question is, where do they go? Well, sine is opposite over hypotenuse. So that means, and remember, this is theta. That's the reference one we use. So the opposite, this vertical side must be 3, and the hypotenuse must be 5. Which means we have to figure out x. So x squared plus the other leg squared, 3 squared, is equal to the hypotenuse squared. X squared plus 9 equals 25. X squared equals 16.
Therefore, x is plus or minus the square root of 16.
which is 4. But which one am I using, plus or minus?
Plus, because I'm in quadrant 1.
Now we can answer these two questions.
Well, what's sine 2 theta the same as? 2 times the sine of theta, well, we used alpha.
That's the formula for sine 2 theta.
Well, we know sine theta.
What is that? We actually know the value.
3/5.
And the cosine of theta, we can look at our triangle and figure it out.
What's the cosine of theta? 4/5, adjacent over hypotenuse. And then just multiply those.
Remember, 2 is the same as 2/1. And you get 24/25. Okay. Cosine 2 theta, you got 3 formulas to choose from. It doesn't matter which one you use, you'll get the same answer at the end.
So I'm just going to use the first one. What was it? Sine squared minus, no. Cos squared minus sine squared. I know cos theta, we found it over here, it's 4/5. And I have to square it. We know sine theta is 3/5, and we're asked to square it. So this gives me 16/25 minus 9/25, which simplifies to 7/25.
And that's it. Okay. So those kind of questions, remember, those, for lack of a better phrase, I just say those are the kind of questions where we're finding trig values using a coordinate grid and Pythagoras.
Okay, where else can we use these? If we're asked to prove identities. Remember, this is when we've got to make the left side equal the right side.
Sine 2 theta. Remember, we want to get sine thetas and cos thetas. That's what we want. I don't want a sine 2 theta.
This is the same as what? Sine 2 theta. 2 sine theta cos theta. It is a double angle identity. Double angle identity.
I can't go any further on that side. So somehow I got to make the left side look like 2 sine theta cos theta.
Well, I got some tan theta, so I got some work to do. Tan theta is the same as what? This one you have to know. You're not given it. Tan theta is sine over cos. And then on the bottom, tan squared theta is the same as sine squared theta over cos squared theta. What's an easier way to say the top of this big fraction? 2 sine theta over cos theta. That's as far as I can simplify
The top of the big fraction.
the bottom. Well, I can combine these two into a single fraction.
So remember, 1 is the same as 1 over 1.
I gotta combine these two by making a lowest common denominator of cos squared. What's the lowest common denominator of 1 cos squared?
1 times cos squared, which is just cos squared.
What do I have to multiply this one by to get this denominator? I have to multiply top and bottom by cos squared theta to get this denominator. So therefore, that first fraction, 1 over 1, is the same as cos squared theta over cos squared theta. I don't have to change the second fraction because it's already over cos squared theta. What would you like to do now? Sorry.
Change it to multiplication, sure, or
Yeah, we could just, before we multiply, we could just say, oh, that's 1.
I don't think you want to be doing grade 9.
Now we can multiply. Well, the fraction up top, 2 sine theta cos theta, multiplied by the reciprocal of this, which is cos squared theta over 1. I can take out a cos squared theta from each of those, but I still have a cos theta here.
Here it comes, there it is.
Finally, I got the left side.
I had to do a lot of work on the left.
Okay. Can you try that one? See how
It's as far as you can go on the right. Okay.
hey, you notice that? For this one, sine 2x on the bottom, there's only one choice. Change it to that.
This might be the tricky one. It doesn't, remember, it doesn't matter which one you use. Okay, you can use the cos squared x minus sine squared x. You can use the 1 minus 2 sine squared x or 2 cos squared x minus 1. Do you have a preference?
You want to try that? Okay, so we're going to do 1 minus, and remember, you have to plug it in parentheses. That could be the trickiest part of the numerator.
Because it's going to change the sign to plus.
So you're going to get 1 minus cos squared x plus sine squared x. choose sine x cos x. You want to change this to 1 minus cos squared x, or you want to change this to sine squared x? Sure, absolutely. So up top, it becomes 2 sine squared x. And now I can do some canceling. I can cancel 2's. Times 2 divided 2 is 1. So take those. I can take out a sine of each one. And I'm left with sine x over cos x. Nice. Not the only way to do it. If you decided to use a different one,
As long as you did everything correct after that, you're going to get the same thing. Okay.
okay,